All right, we're looking at the Unit 1 review. Deciding which ones are functions. We can kind of go through and decide function or not a function on each one. For a function, for each input, there's exactly one output. 2 always goes to 3 here. 3 always goes to 5. 4 always goes to 5. So that is in fact a function. It can have the same output, but not the same input. No single input can go to more than one place. Part B, 4 goes to both 5 and it goes to -5, so that makes it not a function. C, we're looking at a vertical line test. If we think about a vertical line going through it right there, it would hit it in more than one place, so it's not a function. Part D, we've got 1 going to 2, 1 going to 3, so that makes it not a function. And then E, anywhere we put a vertical line, it will hit it in at most one place, so that is in fact a function. So both A and E are functions. The other 3 are not functions. All right, we've got the scenario. Shutterfly is charging 15 cents for each print. So we're going to take 15 cents and multiply it by the number of prints. And then they also add $3 for shipping. So flat shipping charge, multiply 10 times 15 cents, you get $1.50. Add that to the 3, you get $4.50. 15 cents times 20 prints gives us $3. 3 plus 3 gives us $6 for the total cost. 15 cents times 40 prints, $6 plus 3, $9 total. And then 15 cents times 100 gives us $15 plus 3, $18. Now for Walmart, they're charging 10 cents per print, but there's a $5 charge for shipping, I should say. So 10 prints, 10 cents each, that's $1, plus the $5 shipping, that's $6. 10 cents times 20 gives us $2 plus the $5, $7 for total cost. And then 40 prints times 10 cents, that's $4 plus 5 is $9. Again, we're multiplying before we add because of order operations. And then if we have 100 prints, that'd be $10 plus the 5, $15. We can write expressions for these using n instead of those numbers that we're substituting in. If we put an n there, now we'd have 15 cents times n plus 3. For Walmart, we'd have 10 cents times n plus 5, excuse me. So those are the expressions for those functions. In this case, we've got 2 variables. If you're not sure about what to call the variables, you can look back if they've got a table. Oftentimes that'll match up. So we've got number of prints and then we have cost. So which one's independent? Which one comes first? If we know the number of prints, we can calculate the cost. And most customers would decide the number of prints first and then see what the cost would be. So cost is dependent. When we write a sentence using a dependent and independent variable, it's the dependent depends on the independent. Dependent is a function of the independent. So cost is a function of the number of prints. We're going to use S for the cost at Shutterfly, and we're doing this in function notation. Function rule, simply an equation. Function notation means we want to put the independent variable inside of the parentheses. So cost for Shutterfly as a function of the number of prints, that's equal to, remember it was 15 cents times the number of prints plus $3. And then for Walmart, the Walmart, the cost depends on the number of prints. Cost is a function of the number of prints. It's equal to 10 cents times the number of prints plus $5. So we wrote function rules and function notation. Now I've already kind of mapped out the, chosen a scale horizontally of 10 and I labeled every other one, and then vertically I chose a scale of 1 and labeled every other one. Notice we've got number of prints, we've got cost. Alright, so if I use blue for Shutterfly, now we're plotting all of the points from the table. So we're going to plot a point at 10, 4.5, 26, 49, 100, 18. Plot all of those points for Shutterfly. So 10.4.5, 26, 49, and then 118. And then we'll do the same thing for Walmart. If you've got two different color pencils, you can do that, or you can use two different symbols. All right, so Walmart, we have a point at 10, 6, and then 27, and then 49, and then 115. You can label your graph something to summarize this. I'm going to say print comparison. If you want to, you can draw lines through those since they happen to be linear equations, but it's not a big deal. 15 cents corresponds to which of the following on Shutterfly's graph? Well, 15 cents was the number that was multiplied by the number of prints. So that's that rate of change or slope. For Walmart, $5 was the place where you started out. It was a one-time fee for shipping, so that's your y-intercept. If we extend Walmart's graph out, we should see that it will intersect right about 5. If you're ordering from Walmart, you're starting out at a $5 cost, and then even if you just got one print, it would be $5 plus, in this case, 10 cents or 5.10. Do the graphs intersect? Yes, they intersect right there, that point 49. You should notice in the table that it was the same. So let's give the coordinates of the point. Number of prints is independent, so it comes first. And then what does it mean in this scenario? 40 prints cost $9 at each company. Find the total cost at if the total cost at Shutterfly is $5.25. So find the number of prints. We're substituting into that S of n function that we built on number 6, and then we're going to solve for n. So replace S of n with $5.25. That's the cost at Shutterfly. And then our expression was on the right side was 15 cents times the number of prints plus $3. Solve that, subtract 3 from each side, you get 225 equal to 15 cents times n, and then divide by 15 cents. And hopefully you'll see that 15 prints is what cost $5.25 at Shutterfly. What does this mean? W of 50 equals $10. So W is representing the cost at Walmart. Cost at Walmart of 50 prints is $10. Notice that it does not mean W times 50. This is function notation. Based on the scenario, when or with how many prints is it cheaper to buy from Walmart? Well, we see them intersect at 49. So at 40 prints, they both cost the same. So anything to the right of 40 for Walmart is going to be less than Shutterfly's. So it's cheaper to buy from Walmart when you purchase more than 40 prints. We're trying to match up these equations. For y equals 2x, do a little xy chart, just find a few values. If we put 0 in, 0 times 2 is 0. So we have a point at 0, 0. If we put 1 in, 1 times 2 is 2. If we put 2 in, 2 times 2 is 4. So we've got a point at 0, 0, 1, 2, 2, 4. None of the other graphs have those same points, and so choice A matches up with 14. So we've got that one out of the way. 15, we're going to square it and then multiply it by -1. So again, if we do a little xy chart, put in a few values. If we put 0 in, 0 squared is 0. If we put 1 in, 1 squared is 1. Make it negative, or the opposite, we get -1. If we put 2 in, 2 squared is 4. The opposite of that, -4. So we have a point at 0, 0, 1, -1, 2, -4. And so we see that choice C is the match for that. 16, hopefully you recognize this symbol as a step function. The only step function we see is choice E. So 16 matches up with E. 17, we can do an XY chart. This time we're multiplying it by -2, and then we're going to add 1 to it. 0 times -2 is 0, plus 1, 1. 1 times -2 is -2, plus 1, -1. 2 times -2 is -4, plus 1, -3. So we're looking for a graph that includes all those points. 0, 1, 1, -1, 2, -3. B is our match. Domain, what's the domain? Domain is all of the x values. -3, -1, 4. If they were out of order, we'd fix them. Order them from least to greatest. The range is all the y values, and so we get 1, 0, and 0. We're going to put them in order from least to greatest. If they appear more than once, just list it once. 20, we're going to put 7 into this function. Got -4 times 7 plus 6. Multiply first because of order of operations, and then add, and we get -22. 21, we're going to put 4 into the f function. See what comes out. 7 times 4 gives us 28. Then we're going to find out what happens when we put that into the g function. So now we're up to finding g of 28, which means replace x with 28. And we get 25. So we can say g of f of 4, that original expression, is equal to 25. Put 4 into the f function, then into the g function. Here we're going to put 1 into the g function. That gives us 3 out. Then put it into the f function. 3 goes in, and we get 2 out. Again, we put 1 into the g function, got 3 out, and then put 3 into the f function, got 2 out. Restrictions are values that don't give you a real number. Those are restrictions on the domain, are values for x that don't give you a real number. We cannot divide by 0. So if we set the denominator equal to 0 and solve this equation, we'll figure out what x value causes the denominator to be 0. Subtract 4 from each side, you get -4. Divide by 2. And so we get x equal to -2. Our restriction is that x cannot equal -2. If it does equal -2, then you have division by 0, which is undefined. 28, find the domain of g of x. If we put in we can't have the square root of a negative number and get a real number out. So if we set that stuff underneath the radical, it must be greater than or equal to 0. It can be 0. We can take the square root of 0, which is 0. We can't take the square root of a negative number and still be in the real number system. So let's add 5 to each side, and we see that x must be greater than or equal to 5. That is the domain of this function. You could also write it in interval notation, everything to the right of 5. Hope you've enjoyed this video.